And welcome, ladies and gentlemen. Mr. Callan here to help you with today's lesson. We'll call it Lesson 10A4A, but really it's Lessons Chapter 11.1 in the textbook and Chapter 11.2. Today we are exploring three-dimensional figures, but go ahead first. Pause, whatever assignment this is, pause for page 321. Check your answers. Come on back when you are ready. And so for today, our objectives are I will name three-dimensional figures. So first we have to classify, we have to name them. But also, we need to identify vertices, edges, with a special focus today on faces. What we're eventually going to be doing is using that to find surface area. In other words, how many squares of wrapping paper would it take to cover that birthday present that you are going to wrap? All right, pause your video if you need. Go ahead and title your paper, whatever assignment, name, date, period. Page 307, number 14. Page 309, numbers 9 to 23 odds, and 24 to 26 all. Pause, come on back when you're ready. And so here we go. I'm going to actually ask you to number your paper 1 through 7 and figure out what shapes these are. See if you can do it. Again, pause and come on back when you're ready. Now please notice, got a big difference between the first row and the second row. First row, if you look at the orange, you'll notice several shapes. They have edges, they have faces, vertices, but they particularly have two orange faces that we call the bases with the B as in boy. Now, because they have two bases and a number of rectangles, those will all be prisms. On the other hand, the second row, numbers 5 through 8, they do also have edges, vertices, faces, but they only have one orange colored base each. Because they have one base and are then surrounded by a bunch of triangles, these of course would be called pyramids. And so number 1, because it's a prism with a triangular base, we would call that a triangular prism. Number 2, because it's a prism with what appears to be a square or, hard to tell, rectangular base, we'll call it a rectangular prism. Number 3, of course, would be a cube, all faces being square. Although on my screen it looks a little squashed, but I think we did a pretty decent job of showing those are all square faces. And number 4, each of those bases, 1, 2, 3, 4, 5, 6, that is a hexagon and thus a hexagonal prism. Now, if you take a look at the second row, number 5, triangular base, triangular pyramid. Number 6, is that a square or rectangle? I think that's a square base, thus a square pyramid. Number 7, 1, 2, 3, 4, 5, pentagonal base, pentagonal prism. And number 8, 1, 2, 3, 4, 5, 6, hexagonal base, hexagonal prism. So first two rows, if they have edges, first decide if they're prisms or pyramids, and then name those prisms or pyramids by the shape of the base. Numbers 9, 10, 11 have curves. Number 9, of course, being a cone, having only one face. Number 10, two faces and a curved surface around them makes for a cylinder. Number 11, not a single face, not a single edge, not a single vertex, and therefore a sphere. At this point, I would ask you to pause your video, go back to your agenda, and may I suggest, please, going in order, starting with the top, identify parts of 3D shapes on Khan Academy. This will be, I don't remember how many questions there are to it. I was hoping that would go straight to it. I'll see if I can figure out that link. And the second part, identify geometric solids of 3D shapes. And again, I'll do my best to see if I can get those links to go straight to what we're looking for. And we'll figure that out. We'll figure it out together. Onward we go. Here's some notes, 3 examples for today before starting up our homework. We're going to find the cost of making each figure. In order to make the figure, we have to add certain quantities of shapes. So for instance, number 1, I'm seeing a pyramid. We have one base, and we have then a number of triangles surrounding it. So one thing I like to do is just kind of take it apart. Some people, and we'll talk about this on Monday, will do something called a net, where it's almost like peeling apart an orange. But we'll talk about that more on Monday. For today, what I'm going to do is I'm going to say, well, look, I see one square base. That's a 32-cent square. Then, let's see, I see a triangle, big long triangle in the front, which also means there's going to be a triangle in the back. So that's a second large triangle. Now I also see a large triangle on the right, and then naturally then there would be a large triangle on the left. So one square and 4 of the long elongated triangles. In order to find the total cost of making the shape, we would have to add up all of these quantities. And if we added up 32 cents and 4 30-cent triangles, we would then find a total cost of $1.52. Now, if you want, pause, do the next 2 examples, come on back, fast forward the video. For the rest of us, let's go ahead and dig into it. You know, again, I'm seeing 1, 2, a triangle in the back and a triangle on the bottom. I'm seeing 4 triangles once again, which basically was the same thing as what we just did. But in this particular case, ladies and gents, I'm not seeing just one square. We have one on the back, one on the front, excuse me, and then there would be one on the back, one on the top, and then one on the bottom. And then what you might not think about, while you can't see it, there would be one on the left. It's almost a cube, but a cube would have 6 faces, and we don't need, in order to make the shape, we don't need that square, I don't know how you would say it, connecting, or it's kind of a hollow shape, I guess. So you don't need that square right there. So 5 of these 32-cent pieces, you could even write it like that, 5 32-cent pieces, 4 30-cent pieces. In order to find the total cost, we would add everything together. In so doing, 5 32-cent pieces, 4 30-cent triangles, add that up. Final cost here would be $2.80. And again, I would encourage you to pause, try the next one on your own. So what I'm seeing here are a number of large rectangles. I wonder if you could decide how many rectangles would be there. If you have a front and a back, if you have a top and a bottom, I'm seeing 4. So we're going to have 4 64-cent rectangles. All right, now I see some smaller triangles. First time we're using these 15-cent triangles. But the question is how many? So I have one on the front, and then there'd be one on the back. Notice this top part, that right above, that's a square. So we're not going to need that yet. We'll get to that in a second. So I'm counting one triangle on the front. Oh, here's another triangle on the front, which means there's going to be another triangle on the back. Once again, I'm seeing 4 15-cent smaller triangles. Now, let's get to that square, shall we? So how many squares would we have? If that's connecting that guy, then there should also be another square touching this piece on the bottom. So I'm counting one square on the top, one square touching that along this particular edge, so fold it over. So 1 and 2. Then there would be a similar situation here, 3, and then touching that on the bottom would be 4. Oh, it's another 4. 32-cent squares, we're going to need 4 of them. 15-cent triangles, we're going to need 4 of them. 64-cent rectangles, we're going to need 4 of them. If we were to add all these shapes up, we would find that this particular quantity, $4.44. Now you can pause the video, you can rewind if you need to, fast forward on. All we have left Heading into the homework assignment, I would suggest do page 307, number 14 first. Looks easy, looks can be deceiving. Take your time. Some of you have a spatial intelligence. You can do quite well with this. The rest of us need to really take our time. How many faces, how many edges, how many vertices? Then head back to page 309. And my suggestion is do number 15 and 21 first. If you could do those two, you can be good for the rest of the assignment. Carry on with the rest of the assignment when done with those problems. Thanks, folks. That's all I got. Let's grow. See you.